Please let me welcome Pavel Král, who is going to talk about large language models across the different languages. So I bet this will be a really interesting talk, and I see there is a lot of people in the room. So please give warm welcome to the Pavel.
Thank you. Before I begin, I will ask again, who used language model APIs? Like, have you used, okay, so 5, so we have more people, so maybe 10 people in the room use language models over API. Hopefully you will find it useful because this is about the language models, how they can be used over API. Before I begin, I'm one of you. I am not a data science guy. I am Python developer, PyTest, CI/CD, and all that. So this will be very hands-on, and I hope you will learn something how you can integrate language models even into your projects, because I find it very fascinating. In this talk, we will talk about those subjects: tokens, embeddings, and reasonings. That's probably something you people who raised your hand already encountered. So tokens, what are the tokens? Everyone is talking about the tokens, how much do they cost, and so on. So we will, for example, look what are tokens and how they are counted. Transformers works with numbers. If you type something into ChatGPT, the string you send into ChatGPT needs to be transformed into numbers, because transformers do not like string, they like numbers. So if you type something into ChatGPT, it needs to be translated into numbers. Then it goes to transformer, and transformer spits out the tokens, and then the tokens are translated into string. So if we are speaking about tokens, we are speaking about those lists. Those lists of integers, they are tokens. So if we are speaking about tokens, how much do they cost? How many tokens do you have? It's nothing special. It's this MyPy definition you probably know from your code base already. If you want to count tokens locally, there are multiple ways how to do that. If you use OpenAI models like GPT-3 or 4, you can install a library called TickToken, which will allow you to translate the string into the tokens. If you use open source model like Mistral, for example, you can use tokenizers library from Hugging Face. There is something special about Google. From my understanding, there is no public library which will allow you to translate the string into tokens. There is only API which will tell you how many tokens the given string represents, nothing else. So if you want to play with the tokens, you can install the TickToken. And if you are speaking about the GPT 3.5, for example, and you want to translate the string into tokens, so we get the string ahoy and we translate it into tokens. So we get some numerical representation of tokens. We also can translate token 0 into the string representation, and we can also iterate through the vocabulary. Vocabulary is the term for which number of tokens do we have and which string do they represent. So that's TickToken. It's library for OpenAI models and OpenAI tokenizers. If you want to play with some open source models, you can use tokenizers library from Hugging Face, and you can easily just define, okay, I am playing with Mistral, and I would like to translate the string into tokens for Mistral. And for the same string, again, yes, you can get the tokens, you can translate the tokens back to the string, and you can iterate through the vocabulary. So you can dig deeper what the tokens are available and which string do they represent. And in this slide, we have it all together. We are translating same string, ahoy, with multiple tokenizers, Mistral, GPT 3.5, 4. And what you can notice here is that basically the Mistral tokens, we can see there are more tokens for Mistral, and they are different. And also we can notice the tokens for 3.5 and 4, they are same. So you can already notice that the tokenization for different models differs. If we are speaking about tokens, it's different for most models, but not some. For example, 3.5 and 4, they are same. And for the Google, you don't know. There is, I'm not aware there is something like tokenizers, for example, for Google. I don't think you can do pip install whatever, and you can install that. So you can only use API, and the API will tell you, okay, it's 645 tokens. That's it, nothing else. Which can be complicated. And you may be asking, why should I care about tokens? I am only interested about strings because I want to ask and I want to get answer back. Why should I care about tokens? Maybe you should care. Maybe you want to know how much will it cost? How much will it cost to translate, to process my message? Or will it fit into the context window? Is it too big, for example, my information? And you want to do it locally before you send your request. That may be helpful for you. Or maybe you have seen this picture somewhere on Twitter. It's a benchmark which explores if the information is hidden somewhere in the message at the beginning or at the end. So it's a benchmark which explores that. And for that, you want to know where your message is. Is it at the beginning or is it at the end? So if you want to do something more advanced, rather than just asking information, you want to have a local tokenizer. We will look into token counting because it's a very interesting subject. In the following text, in the following charts, I will use this text. It's Saturn V article in English Wikipedia. It's about Apollo rocket, and I will be using that for the following slides. And I used it as source information, the English Wikipedia article, and I use DeepL API to translate it into multiple languages. It's around 30 languages, and what you should notice here, on the all following slides, the languages are ordered as they are on the globe, with the Britain being first, West Europe, Eastern Europe, Asia, you get it. Because if we look to the tokens this way, something interesting will appear. The tokens somehow behave to the languages which are closer to each other. So notice the order on the charts I will show you. And also the models I have explored, the OpenAI models you probably know, also the Gemini from Google, and some open source models also. So that's the models we will explore in the following slides. So this is the number of tokens for the Saturn V rocket translated into multiple languages for all the models. You may notice we will dig deeper into the different charts. You can notice there are languages on this axis and number of tokens on this axis. You could notice, okay, it's the same information. It's still Saturn V rocket, but some languages for some model, for example, is crazy high. Okay, what's going on here? Let's dig deeper. First thing, OpenAI models share the tokenizer. So if you are using 3.5 and you want to switch to 4, for example, it's same tokenizer. So there is no difference for you. It could be easy. So what you could notice, the languages are tokenized differently. If you are speaking in Slovak, for example, to your ChatGPT, it will be represented by different number of tokens, which means it will be slower and it will cost you more money. If we look into this, this is GPT-4, English is here. It's very little tokens. It's roughly half of the tokens if you speak in Slovak to your ChatGPT, for example. And obviously, Greek, it's roughly 4 times the token compared to English. So that's something you should notice. If you are, for example, building your startup and you are writing your prompts in Slovakia, for example, it costs you just on the tokens, it costs you roughly double the number of tokens compared to English. And also, you are depleting your context window. So it means if you just switch to English, you could fit more information into the context window. So that's something you should keep in mind. Language matters a lot. And also, as I mentioned before, the languages are ordered as they are on the globe. Britain is first, the West Europe and so on. You could notice some patterns that the languages somehow behave similar. The Gemini, the tokenizer, is different. You could notice there are no peaks like the Greek. Yes, the Greek, they are still the biggest, but it's much more leveled. I think the training data set for the tokenizer was more balanced, maybe, I don't know. But you could, that's something you could notice. So if you are using Google AI, maybe you should be aware of that. Also, Mixtral and Mistral, you could notice the same pattern. So they share the tokenizer. And Llama, if you want to play with the small Llama and big Llama, there is no difference. Again, on the x-axis is the languages, and this is the number of tokens. So you could notice, yes, Greek, they have the specific alphabet, from the math classes. And there is something special about Korea and so on. So what you should remember, if you are building a startup for Greek market, I have bad news for you. It will cost you a lot of tokens for the most models. Maybe you should think about switching to English. It could save you money, and also it could save you the context window. If we compare this is only the non-OpenAI models, and I compared the number of tokens compared to OpenAI models, because now we know the OpenAI, they share the same tokenizer. What you could notice here, for the Google, for the Gemini, you need roughly 20% or 15% less tokens for the same information. We are still speaking about the Saturn V rocket, same text translated. So basically the Gemini, it's using bigger vocabulary, and you need less tokens. So if you are speaking, for example, 1,000 tokens for Gemini and OpenAI, you could squeeze more information into same number of tokens. It's the same information, but basically the tokens represent more of that. And on the other side, the open source models, you need more tokens to encode same information. So if you want to run your startup on Llama, for example, and you need 1,000 tokens for OpenAI, on Llama you will need more. You will need roughly 15% more tokens just to process the information on Llama, because the vocabulary of the tokenizer is smaller. You may be asking how diacritics affects all that. So I removed diacritics from the translation of the Saturn V rocket. What you could notice, you need less tokens to represent the information. Some languages are affected more. For example, the Latvian and Lithuanian, they are affected a lot. We are also affected roughly 15%. So for example, if you are building a product and you are running out of context window, if you remove the diacritics, you can save roughly 15% of your tokens. But again, Google is special in this case. You could notice for GPT-4, you decrease number of tokens a lot, but Google is not that affected. I don't know what's special about their tokenizer. I don't know what's going on there, but I just noticed this pattern. Now we will look into pricing, which is something you may be interesting for you if you are building some startup, for example. The most models, for example, the OpenAI, they charge you per token. So now we know what the tokens are, and if you want to use API, you are charged per token. Also, if you want to host the open source models, you probably don't want to mess with GPUs and all that stuff. You are paying someone to host the model. Those services also charge per token, most likely. Or in my case, I tested the Replicate API. And Google is special. It doesn't charge per token, but per Unicode character, which has some consequences we will explore later. Before I show you following charts, you should keep this in mind. GPT-4 is much more expensive than GPT-3, and it will make sense for you later. This is the price to process the Saturn V rocket, and it's the GPT-4 is just much more expensive than anything else. And you should keep this in mind. If we remove GPT-4 from this chart, you could notice Llama is the most expensive. It's even more expensive than GPT-3. So if you are speaking about open source models, how they are cheap and affordable, they are not. Once you start thinking about hosting the models and paying for that, it could be expensive for you. And for the Google, because the Google is pricing per Unicode characters, you could notice this. It's Asian languages, because a single Asian character could represent a single word, and Google is charging you per Unicode characters. From my experience, Google is much more affordable for Asian languages. Okay, that's tokens. So we learned what tokens are, how they are counted, and how pricing works for the most services. We will look into embeddings. You probably heard about that if you are playing with language models. It's a big topic and it's an amazing tool to do your stuff. What are the embeddings? It's not magic. It's a way how to represent a string in a list of floats. This is embedding. Please welcome. It's not scary. It's usually fixed length. It's like 1,000 of floats, and this list represents the string on the right side. Sorry, left side. So embedding is nothing more than a list of floats. Again, this is the MyPy definition. It's fixed length. So if you have longer text, it's still fixed length representing your text. If you want to play with embeddings, you probably also want to know what cosine similarity. Cosine similarity is one of the ways how to compare embeddings. You could, it's mathematical operation. Basically, you put two embeddings into the cosine similarity, and it spits out you a number between 0 and 1, most likely. 0 means those embeddings are different. 1 means those embeddings are same. There are some other methods how to compare embeddings, but if you open LangChain and libraries like this, cosine similarity is used most widely. To illustrate what cosine similarity is, basically here I'm computing embedding on two strings, and I'm computing the cosine similarity. What you could notice is basically Prague with capital and without capital, it's 0.9. And if I compare Prague and Praha, it's lower number. And if we compare bigger string and in different languages, Praha je krásná and Prague is beautiful, you get 0.91. So you get it. If you are comparing same string, you get 1. If you are comparing something different, you are getting closer to 0. That's what cosine similarity is, and what you will most likely use in LangChain, for example. There are multiple embedding models available on the market because you need the list of float, you need to compute it somehow. OpenAI offers ADA2, which is the oldest model, but I think like 1 month ago they started offering embedding 3 in large and small. Also, Google is offering 2 embedding models, Gecko in 2 variants. One is multilingual, and also I explored open source models. How do they behave? Those models where I believe they are on Hugging Face, and again I used the Saturn V rocket. I started with the English representation, and I translated it into multiple languages via DeepL. So again, we are speaking about the same text translated to multiple languages, and again the languages are ordered as you find them on the map. This is the cosine similarity of all the models I explored, and basically, long story short, there are all the languages on this axis, all the languages on this axis, and there is usually 1 on this line. That's because if you compare Slovak embedding to Slovak embedding, you get 1. So that's why there is that line. And you could notice a few things. Those are the open source models. Those are the OpenAI models, and those 2 are the Google one. And we will dig deeper. How do they behave? And you can already notice a few things. So those are the OpenAI embeddings, and you could see in the ideal world, this chart would be totally boring because it would be full of 1s. it would mean for example, the Slovak text could be compared to German text, and it would be completely and effortlessly comparable. But what we can see here, those are, I'm not sure if it's visible, but for example, the languages of the Nordic countries it's usually visible here because England is here, and we are speaking about Western Europe, Eastern Europe, and Asia. So you could see the cluster of Nordic countries. Those languages are easily comparable to each other. So if you are building startup, for example, for Nordic countries, embeddings will most likely work for you very well. There are other cluster, Czech and Slovak, where the embeddings are easily comparable. So once you start looking this way to the embeddings from the geographical point of view, if you may, yes, for example, the European languages are also easily comparable. So if you, for example, have some library full of strings and or laws, whatever, those embeddings will work well, for example. But there is, for example, Asia, what you could see here, because Britain is first, Western Europe, Eastern Europe, and then Asia. You could see that is something happening there. For example, Korea. Korea is very complicated to compare with other languages. So if you are, for example, doing something about Korean cuisine, for example, it will be complicated for you to compare Korean embeddings to other. And that's the Czechoslovak cluster, which means basically that the embeddings could be easily compared between our languages because, as you probably know, they are very similar. I also tried, on the previous slides, we were comparing the same text translated into multiple languages. I also tried compared the same text, Saturn V, and compare it to Chinese article about motor oil. I wanted to do something completely different. What you could notice here, the new OpenAI models, they return very low values. They will, for the or translation, if you compare, for example, Greek text with the Chinese article, they will return 0, basically the embeddings. So they are very special in this case. And the open source models are not performing that well. We could talk about this for hours. I will show you a little example how we can use embeddings. I'm using kimchi here because it's Korean dish, and you probably already know from the previous slides that the Korean language is somehow special. So I will be using Czech article about kimchi, which is Korean dish, and I will be comparing it with some other texts. For example, Czech article about apples, Turkish article about strawberries, and Korean article about kimchi. So in the end, what you should expect is that the Czech article should be closer to the Korean kimchi article or to the Slovak article. I translated the Korean text into the Slovak language. What you should expect that the cosine similarity should be same for those languages, and the apple and the strawberry should be somewhere behind. That's what you should expect. But I computed the cosine similarity, and what you could see here, the Slovak is the closest to my Czech article. And if you could notice, the Korean is always behind. And that's because the Korean language, in my experience, is not well represented in the embeddings. So basically what we wanted to do, have the cosine similarity of the Slovak translation of kimchi on same height like the Korean, but it didn't happen. And that's because the Korean language is not performing well in my experience with embeddings. So that's why I think we never get the cosine similarity as high as the Slovak language. I also compared the different texts. I compared the multiple food texts to Chinese article about motor oil. And you could notice the embeddings are of the new OpenAI embeddings return value close to 0. They tell you it's nonsense. It doesn't make sense together. But other models, for example, the open source models, they return 0.9. It's something you should know. That's something you should know, that the embedding models perform differently, and maybe you shouldn't choose just the first one because it works and it was in LangChain tutorial. You should be aware that there are multiple embeddings which perform differently. Okay, that's embeddings. Remember, there are multiple embeddings. There are some embeddings which are specific for multilingual comparison, for example. There are cheaper and more expensive embeddings. Maybe don't choose just the first one, but explore what's behind that. In the last section, we will check the reasoning. Maybe it was only me, but I asked myself always, like, are the language models smarter in English, for example, if I'm asking languages in Czech? So I dig deeper into this domain. So I created a data set of, I'm a space nerd, you maybe already noticed. There was Saturn V, now it's Falcon 9, yes. So I generated a data set of Falcon 9 related questions. It's 11 questions. Why I'm showing here, they are hard. It's nothing like which color does it have. Like they are very complicated. For example, how much money does it cost to develop the program, and so on. Very complicated. You wouldn't guess it. Even I wouldn't guess it. And what I did, I asked those questions to GPT 3.5 in multiple languages, around the roughly 30 languages. And I started with the English question, translated via DeepL to Greek in this case, for example. I asked the GPT, I got the Greek answer, and via DeepL I translated it back to English, and GPT-4 was like a teacher, and it knew the right answer, and I asked it to score the answer between 1 and 5. So it was fully automated, and GPT-4 was like a teacher, and it was checking the answer of GPT 3.5. So that's what I did for 11 questions, 30 languages. This is the result. What you could, those are the questions, like the first question, second question, third question, and so on. And on the x-axis is the languages asked. What you could notice here, the first question is very easy. If I jump back to previous slides, it's this question. When they send humans to orbit, that's the first question. The third question is about the money. How much did it cost to develop the program? So I will just jump back. So this was the first question when they sent first the human to orbit. It was super easy for the most languages. But the second question, they have like 3. The scale is 1 to 5. So the most languages got it wrong. In the how much did it cost? They produced some message, but the correct answer is 360 millions or whatever dollars. But they produced something like 1.6 billions, which is not in Wikipedia. The Wikipedia was like the source for me. So you could notice here there are some patterns that the languages, there are some languages, the languages may reply differently. And when I computed the averages for the all languages on the all 11 questions, you could notice some pattern here. This is one subject. If you make your data set about Slovak history or Slovak cuisine or whatever, this may be different. But in my maybe English-oriented data set, this was the result. The English was producing very good results, and the Eastern Europe maybe wasn't producing very good results. So in my opinion, the languages may differ, and the performance of the questions you ask may differ in different languages. So that's it. I think the language matters. Again, this was my SpaceX related subject. It may be different for your domain. I hope you like my speech. Tomorrow I have workshop. We will be doing some amazing stuff with language models. So if you want to join me, you can find me tomorrow somewhere around. Thank you.
Okay, thanks for the great talk. We have several questions, so let's start from the top. So why do some languages require more tokens when you remove diacritics?
Okay, it's why when you remove, I don't know. It happened only mostly for Google. I don't know. I didn't check the tokens. I don't know. I don't have a answer.
Have you considered also error coming from the DeepL translation when evaluating, like Korean language might not have good enough translations?
That's possible, that's happening. I checked the languages I could, like Czech language and English, I checked that. But yes, I don't have, unfortunately, Korean friends, so I couldn't check it. But yes, I assume the DeepL translations are 100% correct, which is assumption I made and may not be completely correct.
How did you get the translation of Saturn V article? You were comparing tokens counts with, were they taken from various wikis or machine translated? How did you ensure the texts are actually equivalent and some languages don't just contain more or less text added by the translation?
It's DeepL. It's the DeepL is like the biggest translation thing you could ask. Yes. So yes, maybe DeepL was lying to me and producing longer text in Korean. I don't think that's happening because DeepL is very widely used. So I assume that if DeepL is using someone much more powerful than me, it's probably I can trust it also.
Are there available any reliable embeddings models trained on Slovak or maybe Czech language?
I would, if you want to play with the Slovak language, you should notice there are multilingual embeddings. Especially Google says this is multilingual embedding, so maybe you want to use that. I'm not sure about the Slovak, specifically Slovak language. There are definitely some Czech embeddings made by Seznam. I am not aware about Slovak embeddings model because it's not my domain, but I think there is, on this university, maybe they are working on something.
How much did it cost to run the experiment with 11 questions and 30 languages? Just to give a ballpark figure to get an idea.
A lot. A lot. It was around $50, something like that. And the most expensive part was the GPT-4. It was the DeepL was very expensive, and also the GPT-4 was very expensive. The 3.5 is very affordable, so it was like around $50 for OpenAI and something like 50 euros for DeepL. So around 100 euros, dollars, or whatever, around $100.
Have you manually checked that the scoring 1 to 5 by GPT-4 was correct? We typically see that if we ask about confidence score or score in general, the model might be hallucinating. The model is good at generating text, but that doesn't mean it knows the sense or the score of the answer.
I did check something. For example, I was looking for, so I did check some of them. It made sense to me. For example, the models didn't get the amount of money, right? I did check what I could, but it's 11 times 30. It was a lot of questions, so I couldn't check everything.
Do you think there might be a correlation between performance of a given language, for example Korean, and the input data which it was trained on? It might be performing poorly because during the development period did not have the same amount of data like for English?
I think that's what's happening. I did Google something about Korea. Korea is, Wikipedia says it's the only Asian language which types from left to right. So Korean language is somehow special. And also the Korean nation is quite small compared to China, for example. So I think this is caused by the size of the nation. Even if the China is also different from our perspective, China is much bigger, and I think it was represented much better in the training data set. That's, I think, what's happening.
Why did you choose GPT 3.5 for the reasoning testing and not the quote-unquote better model?
I did play with the GPT-4, and GPT-4 was making it the right answers most of the time. So I wanted to if I have everything created like it's perfect, that I wouldn't explore anything. So I choose some stupid model where I could do something. And I think if I choose, for example, GPT-4 for the same thing. Like for the more complicated questions, it would perform poorly, even GPT-4. So I don't think it matters if you use something smarter, because you still find some complicated subjects where even GPT-4 would struggle.
Did you insert the correct answers to the GPT-4 scoring?
Yes, I used Llama. There is a class in Llama Index which is basically doing it for you, and it has all the prompts and everything. And yeah, you give it the correct answer, and basically there is prompt which tells it to score it from 1 to 5.
Have you also explored situation where the text was cyclically translated to multiple languages and then back to the original?
There was only one translation. It was only from the English to German, for example. It was only there. The question is basically if I benchmark DeepL. No, I didn't benchmark DeepL. If is it producing constant results? No.
And the last question, does it make sense to use GPT-4 via API instead of the subscription if it's really expensive?
You cannot use API without subscription. So if you want to do some Python amazing stuff, you need API and you need to pay for that. And even if you use the subscription, you are still limited to few queries per hour, or I don't remember correctly, but you need subscription basically. You need the API to connect Python.
Okay, I think that's all. So thank you very much for your interesting talk, and thanks again.
Thank you.